So in this experiment, I just put water in there first, and you can see I'm going to add 20 mils each time for the dilute buffer. And so that will now drop down its pH 4 to close to pH 4. And once that's settled, I'm going to add, I think it's base. No, I'm going to add acid first. So I'm going to do dilute versus water with acid, and then later on I'll do dilute versus concentrated for base. So we're looking at whether dilute buffer is better than water or not. And so you can see it start to drip now, so I'm adding the acid. You can see the drop counter there. Now I've put both at the same rate, so I don't change the stopcock, so the rates of acid or base added are constant. You can check that with the green line at the bottom, that's the volume. You can see that the gradient on the volume is the same for the acid and a slightly different gradient, but the same for the base. So you can trust that that's controlled. And so more and more acid's being added. And so that is combining with more A- there because we've added lots of salt there. And so that is getting neutralized. But it only works so well depending how strong the buffer is. Okay. And so now we stop that and reset it. So we're going to compare the first gradient, the gradient we have there with the new one. So replace that with the water, and it'll give it a little bit of time to go up to 7 this time because it's just water. And this time when we add the acid, there should not really be any buffer there. So it'll just drop straight down and be much faster. So if I just jump to that. So you should see that the green line is the same gradient, and compare that line. You can see the little dots even, it's dropping so fast. It's not that clear because it's 1 mole, which is quite strong, and the buffer is super dilute, was, and this one's just water. And so you can see now that they're about the same, but the second one, the water just dropped down much faster. There was no buffer there. So there was nothing there. There was no A- present to absorb some of that H plus and prevent the pH change. So just the addition of H plus just meant more H plus. Now we're going to do one that's slightly different. We're going to go just dilute versus concentrated. So just resetting again with the water and getting that back to a pH 7. This time we're adding base. So the difference with this one will be the base the OH minus will react with the H plus and take the H plus away. So this time the equilibrium reaction will move to the right. And so the loss of H plus will be replaced by the HA instead of just being the H plus being removed. The H plus will be replaced to keep the pH the same. So now we're dropping down sodium hydroxide. And you should see this will be this rate. This green line should be the same as the next green line one. And so we're dropping that in now. No, we just put the buffer in, letting that sit at around pH 4-ish. And now we're adding it. So you can see the green line go up. And that rate is the dilute buffer. So we should see a less steep gradient on the second one when we do the neat. Okay, so have a look at that there. That should be fine. So there was OH added. That neutralized the H plus and was replaced to a point as much as the buffer could do it, but not very well. So we're going to go into neat. So we'll just jump ahead now. And so now we're using a much stronger base, not diluted, and let that equilibrate down to the pH it should be, around pH 4 or so again. If you haven't noticed, it's a bit in between. I accidentally poured it into the beaker rather than into the drop counter so it could slowly release the volume. So we're not doing that one, but that's fine. We've got every other combo. Okay, and now I start adding the NOH. You can see the drops start to fall. And you can see that fourth green line now is so the first and second are the acid, the third and fourth steep gradients are the same because they're the base. And you can see it's much less steep, and now it jumps up a little bit even more, but still less steep than the previous 20 mils, the dilute buffer. Okay, and so what you can do there if you want to get a proper measure is something called buffer capacity. You look at the pH change, just plus or minus 1, so the 1 pH change, and you tell me how many moles of acid it takes to change the buffer by 1 pH, and that's called buffer capacity. So that's how we numerically compare buffers or strength of buffers, that number, how many moles of acid it takes to change the pH by 1. Okay, so that's how we numerize it and quantitate it.